Hello YouTube, welcome to part 2 of Project Habbakuk, and let's begin. So we just got to the part in part 1 where they started building scale models of it. So let's keep going. The decision was made to build a large-scale model at Jasper National Park in Canada to examine insulation and refrigeration techniques and to see how pike would stand up to artillery and explosives. Large ice blocks were constructed at Lake Louise in Alberta, and a small prototype was constructed at Patricia Lake, also in Alberta, all in Canada, measuring 60 by 30 feet, weighing 1,000 tons, and composed by a 1 horsepower motor. Now, this is what it was intended to be. This is not what it turned out to be, but yeah. The work was done by conscientious objectors who did alternative service of various kinds instead of military service. They were never told what they were building. Bernal informed COHQ the Canadians were building a 1,000-ton model and that was expected to take 8 men 14 days to build it. The Chief of Combined Operations, or CCO, responded that Churchill had invited the Chiefs of Staff Committee to arrange for an order to be placed for one complete ship at once, with the highest priority, and that further ships were to be ordered immediately if it appeared that the scheme was certain of success. The Canadians were confident about constructing a vessel for 1944. Necessary materials were available to them in the form of 300,000 tons of wood pulp, 25,000 tons of fiberboard insulation, 35,000 tons of timber, and 10,000 tons of steel. The cost was estimated at £700,000. Meanwhile, Perrotts had determined via the experiments at Smithfield Market that the optimum structural properties are given by a mixture of 14% wood pulp and 86% water. He wrote to Pike in early April 1943 and continued that if certain tests were not completed in May, there would be no chance of delivering a completed ship in 1944. By May, the problem of coal flow became serious, and it was obvious that more steel reinforcement would be needed, as well as a more effective insulating skin around the vessel's hull. This caused the cost estimate to go to £2.5 million. In addition, the Canadians had decided it was impractical to attempt the project this coming season. Bernal and Pike were forced to conclude that no Habbakuk vessel would be ready in 1944. Pike was excluded from the planning for Habbakuk in an effort to secure American participation, a decision that Bernal supported. Pike's earlier disagreements with American personnel on Project Plow, which caused his removal from that project, were the main factor in this decision. Naval architects and engineers continued to work on Habbakuk with Bernal and Perrotts during the summer of 1943. The requirements of the vessel became more demanding. It had to have a range of 7,000 miles or 11,000 kilometers and be able to withstand the largest waves recorded, and the Admiralty wanted it to be torpedo-proof, which meant that the hull had to be at least 40 feet thick. In case any of you don't know, 40 feet thick is an extremely large hull thickness. That would be like a car flying into the side of a building. Like, it would, just smash. It wouldn't go through. And even if it did, it wouldn't make it all the way through. The Fleet Air Arm decided a heavy bomber should be able to take off from it, which meant that the deck had to be 2,000 feet long. Steering also raised problems. It was initially projected that the ship would be steered by varying the speed of the motors on either side, such as you can see here. But the Royal Navy decided the rudder was essential. However, the problem of mounting and controlling a rudder over 100 feet high was never solved. Naval architects produced 3 alternative versions of Pike's original concept, which were discussed at a meeting with the Chiefs of Staff in August 1943. Habbakuk 1, soon discarded, would have been made of wood. Habbakuk 2 was closest to the COHQ model, and would have been a, notice I said would have, because this project was never completed, and would have been a very large, slow, self-propelled vessel made of pike with steel reinforcement. The size would have been a length of 1,200 meters, and a width of 180 meters. Habbakuk 3 was a smaller, faster version of Habbakuk 2. Air Chief Marshal Portal asked about potential bomb damage to Habbakuk 3, and Bernal suggested that a certain amount of deck covering might be ripped off, but could be repaired by some kind of flexible matting. It would be more difficult to deal with bomb holes in the center portion, so the roof over the aircraft hangars would be made of blast-proof against 1,000-kilogram bombs. Bernal considered that no one could say whether the larger Habbakuk 2 was a practical proposition until a large-scale model could be completed and tested in Canada in the spring of 1944. He had no doubts about the suitability of pike as a material, but said that constructional and navigational difficulties remained to be overcome. The final design of Habbakuk 2 gave the Berg ship, as it was called, a displacement of 2.2 million tons of water. That's a lot. Steam turbo generators were to supply 33,000 horsepower, or 25,000 kilowatts, for 26 electric motors mounted in separate external nacelles, which are normal internal ship engines Actually, no, nacelles would of course be these, because for the reason normal internal ship engines would have generated too much heat for an ice craft. Its armament would have included 40 dual-barreled 4.5 dual-purpose turrets and numerous light anti-aircraft guns, and it would have housed an airstrip and up to 150 twin-engine bombers or fighters. According to some accounts, at the Quebec Conference in 1943, Lord Mountbatten brought a block of pykrete along and demonstrated its potential to the admirals and generals who accompanied Winston Churchill and FDR. Mountbatten entered the project meeting with 2 blocks and placed them on the ground. One was a normal ice block, and the other was pykrete. He then drew his service pistol and shot at the first block. It shattered and splintered. Next, he fired the pykrete to give an idea of the resistance of that kind of ice projectiles. The bullet ricocheted off the block, grazing the trouser leg of Admiral Ernest King, and ended up in the wall. Sir Alan Brooke's diary supports this account, telling how Mountbatten brought 2 blocks, one of ice and one of pykrete. After first shooting at the ice and warning to beware of splinters, Mountbatten said, "I shall now fire the block on the right to show you the difference." Brooke reported the bullet rebounded out of the block and buzzed around our legs like an angry bee. Max Perutz gave an account of a similar incident in his book, I Wish I Made You Angry Earlier. This sounds like a very nice guy. A demonstration of pykrete was given at Combined Operations Headquarters, COHQ, by a naval officer, Lieutenant Commander Douglas Adshead Grant, who was provided by Perutz with rods of ice and pykrete packed with dry ice and thermos flasks and large blocks of ice and pykrete. Grant demonstrated the comparative strength of ice and pykrete by firing bullets into both blocks. The ice shattered, but the bullet rebounded from the pykrete and hit the Chief of Imperial General Staff in the shoulder. Brooke was unhurt. So this is Max Perutz's account, and the first one was, second one was Alan Brooks, the guy who was shot, and the first was a general account. By the time of the 1943 Quebec Conference, the Habbakuk Project had won the support of both Churchill and Mountbatten, and was assigned to the National Research Council of Canada because of the cold Canadian winters and Canadians' prior familiarity with ice physics. The small prototype, built in 1944 on a Patricia Lake near Jasper, Alberta, could further researchers' forecasts that the full-size vessel would cost more money and machinery than the whole fleet of conventional aircraft carriers. NRC President C.J. Mackenzie later said British promoters of Habbakuk were so intimidated by Prime Minister Churchill that they kept this information from him until the Canadians' next visit to Britain. Mountbatten later listed several points. Demand for steel for other purposes were too great. This is Mountbatten's points, by the way. I'm not sure if I listed that. Permission had been received from Portugal to use airfields in the Azores, which facilitated the hunting of U-boats in the Atlantic. The introduction of long-range fuel tanks allowed British-based aircraft extra patrol time over the Atlantic. The numbers of escort carriers were being increased. In addition, Mountbatten himself agreed to the project. This would be the demise of the Habbakuk. The final meeting of the Habbakuk Board took place in December of 1943. It's officially concluded that the large Habbakuk 2 made of pykrete has been found to be impractical because of the enormous production resources required and technical difficulties involved. The use of ice had actually been falling out of favor before that, and other ideas for floating islands have been considered, such as welding Liberty ships or landing craft together. Project Tentacle. It took 3 hot summers to completely melt the prototype constructed in Canada. Perutz wrote that he stayed in Washington, D.C. while U.S. Navy engineers evaluated the viability of Habbakuk. He concluded the U.S. Navy finally decided that Habbakuk was a false prophet. Because the namesake of the boat was the actual prophet. One reason was that the enormous amount of steel needed for the refrigeration plant that was to freeze the pykrete was greater than that needed to build the entire carrier of steel. But the crucial argument was that rapidly increasing range of land-based aircraft rendered floating islands unnecessary. The Habbakuk design received criticism, notably from Sir Charles F. Goodeve, Assistant Controller of Research and Development for the Admiralty during the Second World War. In an article published after the war, Goodeve pointed out the large amount of wood pulp that would be required was enough to affect paper production significantly. He also claimed that each ship would require 40,000 tons of cork insulation, thousands of miles of steel tubing for brine circulation, and 4 power stations. But that for all those resources, some of which could be used to manufacture conventional ships of more effective fighting power, Habbakuk would be capable of only traveling at only 8 knots of speed, which is 11 kilometers an hour. His article also contained extensive aggressive comments about the properties of ice as used for ship construction. And Mythbusters have tested this, and so has Bang Ghost Theory, and both of them have concluded that the design is impractical. Impractical? Yeah. It wouldn't be good to design it. But anyway, guys, hope you guys have enjoyed the Project Habbakuk video. By the way, in case you're wondering, this is concept art that someone made. It was never made to fruition, and nobody ever took off from Habbakuk. But anyway, if you would like to ever visit the Habbakuk, there is some very decayed remains at the bottom of Lake Patricia in Jasper Park. Is it Jasper Park? I think that's what it was. Yeah, in Alberta, Canada. I hope you guys have enjoyed this video. Please like and subscribe. Comment down below for future video ideas, and have a good day. Bye.